All right, continuing on with our first section in chapter 10, 10.1.1, we're going to look at another situation with basketball. So it says Rimshot McGee has a 70% free throw average. The opposing team is ahead by 1 point. Rimshot is at the foul line for a 1-and-1 situation with just seconds left. So if you don't know basketball, 1-and-1 means the player shoots a foul shot or a free throw. If he makes the first shot, he shoots a second. If he misses the first shot, then he does not get a second shot. And for foul shots, every shot is worth 1 point. So first thing, take a guess. What do you think is the most likely outcome? 0, 1, or 2 points? All right, so whatever you had there, we can go ahead and actually calculate what is most likely to happen. So we just learned about tree diagrams. So here we go. It says make a tree diagram. Now the nice thing about this tree diagram that's not going to make it as messy is we only have two events, shot 1 and shot 2. And each time we only have two outcomes, make or miss. So it's going to be a much cleaner tree diagram than we had before. So shot 1 is our first event, so that's like our first column. And the outcome when you shoot is that you make it or you miss it. And we know that he's making 70% of his free throws. So chances are, probability is 70% that he's going to make it, which means it would be a 30% chance that he miss it because it has to add up to 1 or 100%. Shot 2 would then be our second column or event. And again, it would be make 0.7, miss 0.3. Now, if he misses his first shot in this situation, he does not get a second shot. So our tree diagram is not going to go on any further here. So we are going to find the probability of all of these. Probability of 0 points, probability of 1 point, and probability of 2 points. So probability of 0 points is if he just misses the first shot, which is just 0.3. So that's his probability of 0 points. His probability of 1 point would be if he makes the first and then misses the second. So make, miss. And remember, this would be, so this is the 0 points. This would be 1 point. And we multiply from branch to branch. So it would be 0.7 times 0.3. If I do 0.7 times 0.3, I get 0.21. So his probability of getting 1 point is 0.21. And then the probability of 2 points would be here, make and a make, which is 2 points, which would be 0.7 times 0.7. Which is 0.49. So in this case, he's most likely to get 2 points in this 1-to-1 situation. All right, so that's the tree diagram. Again, that was a little bit more manageable because we had only two events in each event, or only had two possible outcomes, make or miss. We can also do something called an area model. So an area model is another way to model possible outcomes, and the area model is usually more organized than a tree diagram, which is why I like it a lot. Each dimension of the square represents an event, and since a square has only 2 dimensions, the area model is limited to only 2 events. This means we could not have used the area model for rock, paper, scissors because there were 3 events, 3 people were playing. So that's the downfall of the area model. It is cleaner, but you can only do 2 events. In this case, we do have 2 events, shot 1 and shot 2, so we can create an area model. So for our area model here, I am going to draw a square. And then your events go along your dimensions. So I'll have shot 1 going along the top, and then shot 2 going along the height. And remember, shot 1 has 2 possible outcomes, a make, which is 0.7, and then a miss, which is 0.3. If you want to draw it to scale, you can. You don't have to. You could draw it right down the middle, but I kind of drew it to scale. This is about 70% of that whole length. And then shot 2, again, is a make of 0.7 and a miss of 0.3. But the tricky part to this is, again, if he missed the first shot, he didn't get a second shot. So in this case, we're only going to go and stop here. We're not going to go all the way across. A lot of times we will go all the way across, but in this case, we're not, because he doesn't get a second shot if he misses. So part D we actually already did. And we'll come back with the other ones in a second. So we'll find the probability of all of these. Using our area model now. So the reason it's called an area model is because you find the area of the square, kind of like completing the square. So this is 0.7 times 0.7. That's the area, which is 0.49. And that would be a make and a make, which is 2 points. So probability of 2 points is 0.49. Same thing we had. Probability of 1 point would be if I make the first, miss the second. This is 0.7 wide by 0.3 tall, which is 0.21. Same thing. And then if I miss the first, I don't get a second. So this would be 0.20 points. So this is 0.3 times, this whole thing is 1, 0.3 plus 0.7. So 0.3 times 1 is 0.3. So same probabilities we got above, just a different way of doing it. All right, so we did part D already. Part E says calculated probability of 0 or 2 points. So the word or means to add in probability. So if it's 0.3 chance of getting 0, I do 0.3 plus 0.49, which is probability of 2. So what we're really doing there is finding the probability of 0 and adding to it the probability of 2, which is how we got the 0.3 and the 0.49. So that gives us 0.79. So that's our probability of getting 0 or 2 points. The probability of getting at least 1 point, so think about at least 1 would be meaning 1 or more. So this is really finding the probability of 1 or 2. So I would be finding the probability of at least 1 would be me really doing probability of 1, which is 0.21, plus, because it's or, probability 0.49. And so that would be 0.7. It says many people, when faced with the same problem, guess that the 1 point is most likely the outcome. Their confusion comes from their intuitive understanding of expected value. So what is expected value? So expected value is what you expect to win per play on average based on playing the game many times. The expected value is the sum of all possible values, each multiplied by the probability of its occurrence. And it's often abbreviated with the letters EV. So what did that really mean? You're going to define the expected value. You would take the probability of outcome 1 times the value of outcome 1. And then you take the probability of outcome 2 times the value of outcome 2. And depending on how many outcomes there are, is how many times you're going to be adding this. So I would continue this on until I get to all my outcomes. So in the case for Rimshot McGee, if we're going to calculate the expected value, we would take the probability of 0 points. The probability of 0 points was 0.3 times the value. Well, he had 0 points for that. So that's probability of 0 points. And I'm going to add to that the probability of 1 point. Probability of 1 point was 0.21. So I'd be doing 0.21, and the value there is 1 point. And then I would add to that the probability of 2 points. And the probability of 2 points was 0.49. And the value, he got 2 points for that. And so you go ahead and type that all into your calculator, and you get 1.19 points. So on average, he's going to be getting 1.19 points. So it says if Rimshot McGee were to shoot 100 one-and-one free throw situations, what would we expect to be his average number of points? That's kind of his average number of points, 1.19. But if we are doing this, we can't actually get 1.19 points when we're shooting foul shots. Either you get 1 point or 2 points or no points. So 1.19 is his expected value, which is what most people are thinking about when they probably thought, oh, he's most likely to get a 1 point. But no, he's actually most likely to get 2 points. But if you think about it over a long period of time, he's going to get a little bit more than 1 point on average. That's what expected value means. Looking back here, it says look back at the area model. Look back at the area model created for Rimshot McGee. What are the dimensions of the square? So if we look at the Rimshot McGee, it's 0.7 times 0.3, so this is 1. 0.7 times 0.3 is 1. So this is 1 by 1. So what would be the total area if it was 1 by 1? 1 times 1 is 1. And then it says what probability is represented by the entire area. Well, if we look at this, we'd have 0.49 times 0.21 times 0.3. .49, oops. .21 plus 0.3, which is equal to 1, which makes sense because probability always has to be out of 1. So that's where we're getting the area model. The area is 1 by 1 always. The side of each length is always going to be 1 when you add it all up. The area is always going to be 1 when added up all the areas total as well. So that's our area model.